All right, hello everybody. We're going to go ahead and get started today. We're going to keep going with fossil fuels. We talked a little bit about what dictates what a society might use for energy as it's based on geographic, economical, and cultural reasons. Today, we're going to get more into fossil fuels, talk about what they are, how they work, and how they can supply energy for us. So, in order to understand why fossil fuels are so important, we need to talk about combustion reactions. So hopefully you remember this from chemistry, or if you're a sophomore, you've learned this already in chemistry. But what a combustion reaction is we take some sort of chemical that is a hydrocarbon, and it's exactly what it sounds like. It's carbon and hydrogen in a chain. Now, how much carbon and hydrogen you have, I have X's representing them here, but there's a lot of different numbers these X's could be. It could be C4H8, C2H4, and how many carbon and hydrogens you have in your hydrocarbon kind of dictates what we call it. So you can have diesel or petroleum or what else. But overall, these carbohydrogen chains, these hydrocarbons, which we typically refer to as gas, oil, or coal, are going to be burned in the presence of oxygen. And when that happens, the chemical bonds between these carbon and hydrogen are going to release energy. And that energy is what we're going to use in order to generate electricity, which we'll talk about more here in a second. Now, there are other byproducts of combustion, the first of which is CO2. This is going to be released into the atmosphere, and that's going to be one of the greenhouse gases that we're going to talk about more in Unit 7 and Unit 9. And then also you're going to release water as well. If you've ever been driving in your car and you see water coming out of the exhaust pipe, that is water from the combustion reaction. So what do we use this energy for, and how do we create electricity out of it? Well, essentially what we're going to be doing is running a large steam engine. So we have a water supply coming in from a local river or body of water, like a lake maybe. And what we do is we take fossil fuels, we burn it in this giant pillar here. And then once it's burned, it's going to convert the liquid water that we are bringing in from our water supply, and it's going to convert it into steam. And that steam is then going to be used to spin a turbine. Think of it like a generator or a giant hand crank. That's an easier way to think about it. And this turbine, as it spins, is going to generate electricity in our generator, and that is where our electricity is going to come from. And this is going to be a theme that we're going to see throughout this unit, that a lot of energy that we get is simply just trying to boil water and then getting water to spin a turbine to generate electricity. And how we want to boil that water is going to come through a couple different ways. We can do things like biomass. There are some solar farms that use this methodology, and so does fossil fuels. We can see here the CO2 comes out of this stack. We'll talk more about how we manage this in Unit 7, but just kind of understand the basic principle of how we generate electricity through fossil fuels. Now, as I said before, there are three major types of fossil fuels that you need to know for this class. We have coal, we have oil, and we have natural gas, solid, liquid, gas. Now, depending on which one you use, they're going to have different amounts of impurities. And impurities just refers to anything that is not part of this carbohydrogen chain. So this can include things like sulfur and nitrogens, which are going to be released into the atmosphere. Coal has the highest amount of impurities. It has the most sulfur and nitrogen in it, while methane, or natural gas, is going to have the lowest, and oil is somewhere in between. Okay. Now, oil is widely used for transportation. This is mostly what we use oil for. You can kind of see a breakdown of what we convert oil into. 32% being diesel fuel, think of like large trucks. 27% is gasoline, like for your car that you might use. And then you have other ones like liquefied petroleum gas and kerosene and other fuel oils. But overall, oil is largely going to be used for transportation purposes. However, in order for that to occur, oil does have to be refined before it can be reused. So it's got to go through several processes after we extract it. So here's kind of a cross-section of how crude oil is extracted. Typically, crude oil is going to be extracted from something called tar sands. And essentially what we have here is we have our oil underneath. And what we do is we take steam and we pump it down to where the oil reserves are. And then this steam is essentially going to create pressure into which is going to force the oil into this pipe here, which is going to cause it to be extracted into the well. Once it's extracted, it can be processed and on site and then refined into the type of oil that we can actually use in our motor vehicles or in other appliances. So this version here makes up about 80% of the oil that we extract, while mining makes up about 20%. Okay? Now, crude oil in non-porous rocks are going to be removed using something called fracking. And what fracking is when we have oil that is not in sand but located in solid rock, it can be very difficult to extract. So what we do is we take these large pipes and we run them down to the reservoir rock, which is just a fancy word for where the oil is located. And we pump in chemicals and water and sand in order to create high pressure areas down in this rock. And when that high pressure occurs, it's going to create cracks or fissures, which is going to allow the oil to naturally come down into the pipes and then be pumped up through this process known as fracking. Fracking is going to have a lot of environmental problems that go with it. This includes things like potential groundwater contamination. However, it does allow previously unattainable oil to now be used. So this is essentially giving us a whole new resource of oil in order to try to keep oil prices lower. Now, besides this potential groundwater contamination, there are other issues as well, including the release of VOCs or air pollution into the air. And also, these cracks have been known to create small earthquakes in local areas, which has big impacts on residential and commercial areas. Now, coal is going to be mostly extracted through mining, and there's going to be a couple of different types of coal that you can have, and we separate it based on the quality of coal. So the longer that the coal has been buried under heat and pressure is going to largely dictate what the quality of coal actually is. The lowest quality, and we don't even really consider it coal, it's like a precursor to coal, is going to be peat. And then once that peat is buried for a long period of time, it's going to become brown coal, which is low quality. Now, when I say low quality, essentially what I'm referring to here is the number of impurities and the amount of energy that can be extracted from it. So low quality coal is going to have a lot of impurities and low overall energy being extracted out of it. Next, we have bituminous, which is medium quality. So you can see that the coal here has been under more pressure and more heat. Most of the impurities have been left. That black color that you see is the carbon. So this is much higher as a percent in carbon. So you have less toxins and more energy coming out of it. Most of the coal that we burn is going to be of this medium quality. And then finally, you have anthracite. This is the highest quality. This is almost pure carbon and hydrogen and has the highest concentration of energy when we burn out of it. Typically, when you hear the word clean coal, this is what they're referring to. There's no such thing really as clean coal. Essentially what they're saying is just it has high carbon hydrogen ratio, so it doesn't have as many impurities. However, this is a very rare type of coal to use just because of how rare it is and how expensive it is. So typically energy companies aren't going to burn it because then they'll have to charge their customers more. Now, coal is going to be extracted using mining processes that we talked about in Unit 5. This includes surface and subsurface. If you'd like to go back to Unit 5, highly recommend you go back and look at those. But all of those environmental consequences and problems that we talked about with mining are going to apply to coal as we extract it out. Okay? And then finally, we have natural gas. Now, natural gas used to just be a waste product that was left over when we extracted coal and oil from different rock formations. However, in later years, we've actually learned how to use this natural gas for energy formation. And natural gas is mostly going to form from areas of high heat and pressure. And like I said before, it's going to have the lowest amount of impurities. And what we can do is we can take this natural gas out as we pump up oil and save it and use it for later. So I'm going to show a quick video here. It says I'm offline. Give me 1 second here. Let's see. Just casually see my internet here. All right, let's try that again. All right, so here is that well method that we talked about earlier with oil. So we see the oil coming in here into the reservoir pipe, and it's going to be pulled up through the well. Now, as this liquid is pulled up, some of that natural gas that was naturally pocketed in the oil is going to rise up with it. Think of it kind of like carbonation. You have this mix of liquid and gas. So the oil is coming up the well here. When it gets to the top, it's going to go into something called a separator. And that's exactly what it sounds like. The oil is going to sink to the bottom. Then the gas is going to rise to the top. Now, using density differences, what we can do is, since oil sits higher than water, the water is slowly extracted out and then disposed of later. The oil works its way to crude oil sales, which then has to be refined into those more mature oil sources like gasoline that we talked about. And then any of the gas that was in there is going to rise up and go into the salinity here. Now here you can see that they're burning it. And this is what we used to do. We used to think of natural gas as a waste product. But now we've learned how to cap and seal it, and we can actually move it to different areas and burn the natural gas in order to extract energy from it. So I'll go ahead and finish up this video here. I'm just going to change here. Here you can see we have the gas. They actually put the gas processing lines, natural gas lines. So here they're actually capping it and saving it for later, or they can just run the gas line straight into the power plant and essentially just move the electricity into the city. Okay. All right. That's what we're going to leave for today. I didn't get a chance to talk about fossil fuel extraction in this video, but that is something that we will talk about in class tomorrow. I find it's just a little bit easier to go over in class because there are a lot of steps that are going to go into it. Okay. No FRQ today because we have a lot to do tomorrow, and I will see you then.